It's pretty easy to look for what is the most popular software programming language and pick the top one and say, this is what I'm going to study because I think it's going to help me get jobs. There's going to be lots of support for it. And in some ways, that is true that if you pick a popular language, you'll get lots of libraries, lots of support. But popular doesn't necessarily mean what is going to be popular in the future, like, right? So popular now. And also, it doesn't mean it's the best. In fact, I'm going to do a data analysis based on some factors like the age of the language, also the energy efficiency of the language, and also some of the features of the language, and adjust the naive ranking of popularity based on what I think is potentially the future over the next 10 to 20 years for software languages. So first up here, let's start at the naive ranking. A very popular index is TIOBE, the raw top 10 index. If we look at Python, for example, it's the number one. So it's got 23% market share according to the TIOBE Index. It's a general purpose interpreted language, very easy to get started with. You look at it, a lot of people are using web framework stuff with Python, data science, scripting, etc. So as kind of a general purpose, like documentation almost, Python is a good choice for many people. Why is it so high? It's really easy to learn. There's lots of libraries, really popular in education. But here's where the problems start to crop up, is that it's interpreted. It has dynamic typing, and there's some real performance issues and also packaging issues that are legacy because it's a 30-plus-year-old language. And I think we're going to see this trend as I talk about other languages, is the age of the language really does matter for the future. Now, next up here, we have number 2, C++, 11% market share. Well, one of the reasons is it's very fast, right? That's why people traditionally have used C++. It's an evolution of the C language, but we're also talking about a language that's been around for a long, long time. If you look at the C origins as well, we're talking really more like a 1980s style language, but the real problems are memory management. Bugs are a real issue with C++, and there are some attempts to fix it with modern C++, but we'll get into that in a little bit. Number 3, Java, 10%. There's a lot to like about Java because it has the concept of write once, run anywhere. It has some garbage collection, so it's starting to emerge. Also pretty old though, same age as Python essentially in the 90s, and it can be very verbose. There's some issues with Java. C has been around for a long, long time, 40 something years, 10% market share. It's a foundational language, really high performance, but has tons of things that make it prone to error and security vulnerabilities. It isn't a modern language. And then if we look at number 5, C#, this is a modern language. It's got modern garbage collection. Also, it's high because it has deep integration with Microsoft, game development. So there's some smart people that were involved with C#, but some of the limitations are that it is tightly coupled to Microsoft. In terms of JavaScript, dynamic web language, very popular, 3% or so, large active community, but lots of issues with design quirks and performance. It's a scripting language. SQL has been around forever. In fact, 1970, so we're talking 50 something years, it was talked about in papers. So SQL has been around for a long time, and it does seem like it's going to stay. There isn't really a solution that I see on the horizon for SQL, but it's been around for a long time. Now, one of the emerging ones is Go, right? 2% modern compiled language. And if you look at it, why? Well, just for cloud infrastructure, server-side, command line tools, systems programming, this has some real promise in terms of could it take over a lot of the market share. Pretty new as well, which it can take some of the new design principles and improve things, which I think is a trend. We have Delphi, so object-oriented Pascal, kind of a more of a legacy language, niche. and then Visual Basic also legacy managed language. So you can see here in the top 10, potentially it's not necessarily the best way to think about your career or try to find out what the best solution is. Like, how can you dig into the detail here and get into the age-adjusted ranking of languages, and also dive into other components. So let's take a look at a rebuttal of the top 10 here and maybe have a new change here. So I would say number one, if we were going to adjust based on energy efficiency, safety, also age related, right? Where we're looking at things that are modern. The number one is going to be Rust. If we come up with Rust, the rationale is that it's the gold standard for memory safety without garbage collection, because it has this ownership and borrowing system. It has an amazing package management system, cargo, really good concurrency primitives as well. And so the key strengths are memory safety, performance, concurrency, package management, optimal for really a lot of paradigms, including systems programming. And then if we rank it again, we have Go next. So Go would be a good choice because of concurrency, good package management, energy efficiency. And so it's essentially a workhorse for cloud infrastructure. So Go and Rust here really are starting to take the lead. Now, there's also an emerging language, Zig, here that we could say could be number three. And why would you pick Zig versus Go or Rust? It's designed from the ground up with a focus on manual memory management, but with some safety. So effectively, you could think of it as a more modern C. And if you needed to go a little bit lower level than Rust and get a little bit more performance, a little more speed, and you're going to build some kind of like standalone tool, you can make the case where maybe you also need to know a little bit of Zig. So the strengths here are the fact that you can control manual memory management, and also it has some really good compile time features, and it's a very simple language as well. So it could be really good for systems and embedded programming. Next up here, number four would be Swift. Swift prioritizes safety, performance, and modern language features. It uses Arc for memory management. Also, it has really good design as well. Some of the key strengths here are that it's a modern language with lots of features. So I think Swift is also an interesting one here as well. And then if we get into number five, maybe we look at something like Carbon, and Carbon could be interesting because it's a experimental language designed as a successor to C++. That could be an option. We could also maybe say Mojo also could be an experimental language. And then if we get into some of these other ones like NIM, could be another experimental language. Crystal is designed for developer productivity with a Ruby-like syntax. Odin, a newer language. V, and then you could take maybe a wild card would be C++. So if we look at really how to adjust the naive rankings here, I would say that you should make a focus on modern compiled languages, safety-focused languages, and also concurrency and package management, and shift away from the legacy dominance. Now, if you're a language creator, you, through, I guess, your own vision of the future, want everyone to stay with what you originally created, but that's not how innovation works. Innovation means that you're constantly shifting to new paradigms. If you look at really the ones that are focused on safety, really, you're going to get Rust, Zig, Swift. These are some of the top ones here. Concurrency, we look at Go, Rust, Swift, right? So if we look at this, I would say from doing an analysis based on these other factors of safety, energy efficiency, and also the modern focus, I think the ones that really start to stand out here are Rust, Zig, and Go, and Swift are really strong contenders for languages that are worth investing in. And I would say in particular, the one I've invested the most amount of time in is Rust. But I would say if I had to pick between Rust and Go, I would pick Rust because I like the fact that you get this really great safety and memory story. If I had to then go low level, I don't know if I would pick Go versus Rust. I would more think of it like Zig versus C. And so in that case, I would say maybe the two languages that are the most interesting potentially could be Rust and Zig could be a very interesting combination for me personally. So that's just the way I've thought about some of the things that are happening with the future of programming. I don't see 30, 40-year-old languages like Python, C++, Java continuing to dominate because there are better technologies, better solutions, especially in the age of the coding assistants. Why would you pick something that was designed specifically for readability 40 years ago when you could pick something that is designed for energy efficiency, performance, safety? Those are the things that people are really interested in today.